Hi, everyone, and welcome to today's webinar, How to Build a World-Class Monitoring Strategy with Logic Monitor in AWS. I wanted to thank you all for taking time out of your busy schedules to join us today as we take a deeper look into building a better monitoring strategy. My name is Krista D'Amico, and I am the Partner Marketing Manager here at Logic Monitor, and I will be moderating today's webinar. Before we get started, I wanted to cover a couple quick housekeeping items. This webinar is being recorded, and the on-demand version will be available on BrightTalk within the next 24 hours. This presentation is meant to be interactive, so if you have a question anytime during this webinar, please submit it using the Ask a Question button on BrightTalk. Your questions will be at the end during the Q&A portion. You can also download the slides from today in the attachment portion of BrightTalk. Presenting today from the Logic Monitor team, I have Sarah Terry, who is our Cloud Product Manager. Sarah, would you like to give a quick background of your role here at Logic Monitor?
Sure. Hi, everyone. My name is Sarah Terry, and I'm a product manager here at Logic Monitor. I've been here for almost 4 years now, and I'm primarily focused on our cloud monitoring solution, LM Cloud. I'm super excited to be here talking to you all today about successful monitoring strategies.
Great. Thanks, Sarah. And we also have two solution architects from AWS presenting with us today, Sam and Aaron. Sam, can you start with an introduction, and then Aaron can follow you?
Sure. Thanks, Krista. So my name is Sam Kidder. I'm a Partner Solutions Architect in the Emerging Program within AWS, and I specialize in scale integrations and scale components. Thank you.
And hi, everyone. I'm Erin McGill. I'm a Partner Solutions Architect on the same team as Sam, and I primarily focus on DevOps solutions and on automation tools. I'm happy to be here with everyone.
Great. Thanks so much, guys. So with that, I'm going to go ahead and give Sam with AWS control of the presentation so we can go ahead and get this started.
Great. Thanks, Krista. So this presentation is going to be broken down into two different sections. The first section is going to go over monitoring and logging from an AWS perspective. And once that's done, I'm going to hand the presentation over to Sarah, and she'll finish and give you the Logic Monitor perspective. So why monitor? So most organizations, most companies don't have monitoring as one of their core missions or the product that they're trying to produce or deliver to their customers. But monitoring turns out to be an essential component of really any well-architected infrastructure. And the reason why is because it has an impact on really every aspect of a business. So if you look at it from the external perspective, from the customer perspective, you want to ensure that your customers, whether they're internal users to your organization or end users accessing your application as customers, are getting the best experience that they can. So, I mean, if you have an e-commerce site and you're running a web server, it's not enough just to check to see if the web server is up and running. You want to make sure that the response times to the requests are timely and that they are getting no server errors or anything else like that. So you want to make sure the end user experience is great. From your own internal perspective, you want to make sure that you're sizing your components correctly. You don't want to be running at 90% capacity, but you don't want to be running at 5% capacity. And monitoring the performance of your systems, whether it's CPU, memory, disk space, or any other application-specific metric, is really key for making sure that you're sizing your environment correctly. And both the external and internal views have an impact on how you forecast what your usage will be for your entire infrastructure. So if you can see that you're growing in terms of your end users and your performance on your systems is slowly creeping up in terms of capacity, then you can plan accordingly and budget your purchases for additional hardware or software correctly. And that trending information is really one of the best features of monitoring your environment. So troubleshooting and remediation is also one of the key benefits of monitoring. If you have really good, well-integrated monitoring, then you have the ability to troubleshoot problems really well. So for instance, if you have an event such as a web server reboot or restart, overlaid over performance metrics, and you can see after you restart a web server that the memory consumption of that web server drops dramatically, then maybe you've identified a memory leak in your web server. So being able to have really good monitoring can have an impact on you quickly identifying problems within your environment. And finally, good monitoring, if you have a DevOps type framework where you have continuous integration, continuous deployment, leads itself to really good regression type tests that you can perform. So if you have good monitoring, it's one of the things you can do as part of a new release or a new iteration of a software is just to test out whether all your monitoring tests succeed with this new iteration before promoting it, let's say, to production or to another environment. So it has the ability to make your product better. So what can you monitor? Well, it turns out you can monitor just about everything. So if we look at it from the bottom of the stack here, you can monitor components that are really close to your hardware. So, the raw CPU, network, I/O statistics from the hypervisor, operating system, kernel parameters. These are all, they all expose certain parameters that you can monitor. Taking it a step higher, you can look at off-the-shelf components that may be integrated with your operating system, such as a container or a database or maybe a web server. And these are components that will oftentimes come with their own monitoring framework and will have plugins that will expose certain metrics, so such as JAMX for certain Java-based application servers. And going up a little higher, you're really now into the application stack. And in the application stack, this is where you start running into things where you're going to see more custom type metrics. So response time for a specific URL, for a specific payload that you send to an application server would be an example of an application performance metric that you can track. And these types of metrics, the ones that kind of enter into the stack really at the top, there are different ways of generating those metrics. You can actually monitor real-time end-user connections, or you can create synthetic tests that you can have distributed over a wide network to ensure that you're getting a representative sample of what's happening in your environment. So what tools does AWS have available in monitoring, in the monitoring sphere? There are three core tools we have. AWS Trusted Advisor, which is you can think of it as our best practice monitoring tool. It ensures compliance with best practices that AWS has identified. AWS CloudWatch, which is our performance metric monitoring tool, but it can do a lot more than that. And then we have AWS CloudTrail, which is our auditing tool, which records all the events that really occur within an AWS account. And we're going to go into each one of these individually. We'll spend a few minutes on each. So what is AWS Trusted Advisor? So as I just mentioned, it tracks adherence to what AWS considers to be best practices. And those are best practices across multiple different domains. There are 5 domains that we have, and there are additional domains that get added and modified as times go on. Each domain has a variety of checks that are performed, and the parameters for those checks are chosen by AWS because we consider them to be best practices. So as an example, a cost optimization check would ensure that your load balancer is running at sufficient capacity where it's not impacting your cost. So if it's less than 10% utilization over 4 days, then you're going to get an alert within Trusted Advisor telling you, hey, you're not really using this load balancer. Do you really want to be running it? And there are potential cost savings if you choose not to. So the checks within Trusted Advisor are all kind of predetermined. The thresholds are all predetermined and exposed to people who use it. And they just check their adherence to what we consider best practices. Out of the box, the free version of Trusted Advisor checks really only two groups of information: security and system limits that you may be reaching, such as the number of EC2 instances you're running. But for a small additional cost, you can activate all the additional components and have checks running across your entire environment, such as for cost optimization and performance. The next tool we have is AWS CloudWatch, and this is our tool that we use for being able to monitor really the entire stack of components within a deployed instance within AWS. So it can monitor components at the very close to the hardware level from a CPU, network, and I/O perspective, all the way up to actual metrics within a running EC2 instance, for instance, or any of our services. And those metrics, you can have agents running directly on your servers that publish into CloudWatch. You can have logs sent into CloudWatch. You can even have on-premise hardware within your own data centers send information to CloudWatch through our API. So it is our central place where we keep metric information or log information. What do we do with that information? Well, you can create triggers within CloudWatch so that actions are performed if certain thresholds are met. You can choose what those thresholds are. You can trigger Lambda functions, so you can actually have a full execution of a Lambda, which is a serverless server or a serverless piece of code executed based on some condition that's met within CloudWatch. So it really does have the ability to give you end-to-end monitoring. And this is an example of what a CloudWatch UI looks like. This is CPU utilization on an EC2 instance. Out of the box, CloudWatch will provide you parameters that are updated once every 5 minutes. That's the free version. If you wish to pay for a small additional fee, you can get them closer to 1 minute. And if you want to publish your own metrics into the system, you can go down to a granularity as low as a second. So moving on to the last tool, AWS CloudTrail. As I mentioned, this is our auditing tool. And what CloudTrail attempts to do, well, it does it successfully, is record every single event that occurs within your AWS account. So it answers the question, what happened, which resources were touched during that occurrence, who made the request, when was the request made, and where was it made from. And so these parameters, these values, are all saved as a JSON object. They're typically saved to an S3 bucket, and then you can process them however you wish. But really, it serves as our auditing tool for really anything that occurs within your account. And as a best practice, we recommend having CloudTrail enabled really across all AWS accounts with the log information saved in a secure S3 bucket. And then this is the user interface for CloudTrail, and it doesn't look very exciting because really all it's doing is it's collecting all this log information. So what you decide to do with it afterwards from an auditing perspective is really up to you, but it does maintain a source of truth for whatever occurred in your account. And that's it from the AWS tools perspective. What I'm going to do now is I'm going to turn it over to Sarah so that she can follow up with the Logic Monitor offering.
All right, thanks, Sam. So there are a lot of types of monitoring, many different tools available to help, and modern infrastructure is complex, with resources commonly spanning multiple physical and cloud environments. Many of you are probably dealing with hybrid environments, cloud migrations, and even with multiple clouds. And contemporary technologies and microservices are flexible and they enable agility, but they're also more complicated and are changing how we think about monitoring. So how do you implement a successful monitoring strategy given all of this? I'm going to cover 3 strategies that we've really found to be critical to successful monitoring, and they're high level, but there are a few specific key points within each that are really important. And so I'll dive into the details for each of those. So strategy 1, look at the whole picture. This seems obvious, but there are really 2 main points here. 1, it's easy just to look at performance of resources in the cloud or on premises and consider your monitoring pretty complete, because historically that wasn't too far off for on-premises infrastructure, but that's no longer the whole picture. when you have cloud resources, you're also dependent on the cloud provider's services and really need to monitor not only the availability of those services, but also things like service limits and provider-scheduled maintenance events. This information can be critical to cloud resource uptime and performance. And then looking at ROI and striving to optimize the resources you have in the cloud, both from a cost and a performance perspective, and really making sure that you're running things in the cloud in a way that makes sense for your business. Of course, resource performance is still critical to look at across both cloud and on-premises workloads, but even that can be challenging because the performance of cloud resources is measured and collected inherently differently from the performance of on-premises resources. CloudWatch isn't going to tell you the performance of your on-premises resources without some configuration, and you aren't going to know the complete performance of your AWS cloud resources without looking at CloudWatch. And so that's really the second point for the strategy. If you have a mix of resources across clouds or across cloud and on-premise environments, you need something that's capable of monitoring both to really get an end-to-end view of everything in your environment. So I'm going to dive into the details of what you should look at for each of these three categories listed on the slide. So diving into the resource performance aspect specifically, what performance metrics should you be looking at? What makes it tricky for cloud resources is that traditional device-based metrics aren't available most of the time. Usually, you get around this by relying on data exposed via the cloud provider's API, like the CloudWatch API, which Sam mentioned earlier. Now, depending on the resource type, you may be able to get more or less than this. So, for example, with EC2 instances, you could use an agent to get more visibility into the OS level metrics via SNMP or WMI than you can with a service like SQS. And you can likely also use that agent to get application level monitoring for any applications running on the EC2 instance as well. And that monitoring should be able to use the same protocols and methods used to monitor OS and application level information for on-premises systems. And so all of you guys are probably familiar with traditional agent-based monitoring tools, but at Logic Monitor, we have a collector which differs from a traditional agent in that it's capable of monitoring not just the device that it's on, but also all of the devices within the same network. So that collector sends a few probing requests to identify the device type, so Linux server, Windows server, storage array, etc., as well as any applications that are running, and then uses our library of monitoring templates to map device and application type to metrics should be monitored and how they should be monitored. So making sure that you're capturing performance data and health metrics for both on-premises and cloud resources is going to be really important. But another aspect to consider when it comes to monitoring performance is to look at event data. Events can be really powerful when displayed next to performance data because they can help explain changes in performance data and even shorten the time from issue to resolution. One great way to capture this for AWS cloud resources is by using something like CloudWatch events. And with Logic Monitor, we have an integration in the form of a function in the AWS serverless application repository, which allows CloudWatch events to be added as graphical events on top of performance data, creating a visual event stream. And then especially when we talk about monitoring resource performance for hybrid environments, which can sometimes provide the most flexibility at the best price, it can be challenging to get an end-to-end view of resource performance in a single platform because metrics are coming from multiple sources. But you really need that end-to-end view that can give you continuity from a monitoring perspective and an indication of overall health and where issues are occurring or may occur in the future. So there's efficiency to be gained by being able to gather context across distributed environments in a single platform. And even if you're not leveraging a hybrid environment yet, but are looking towards a future migration, this continuous visibility is especially important. During a migration, you need to be able to look at performance across on-premises workloads and cloud workloads, and you really need that visibility to determine how to size and design the workloads that are moving to the cloud. So Logic Monitor's library of monitoring templates makes it really easy to look at multiple sources of data in a single platform. Because we use a collector to collect data via almost any protocol, it's really source agnostic. So we don't care where the data comes from, which really enables you to have this single pane of glass where you can dashboard, report, and alert across your entire infrastructure, no matter what it's made up of. But all of that really only makes up one piece of the puzzle, and that's the resource performance piece. And resource performance really isn't the whole picture for cloud resources. Arguably as important is the availability of the cloud services that you're relying on. And this really comes down to, if there's an issue that results in your end users not being able to access your application, you need to quickly know and be able to quickly identify what it is. Is it an issue with the availability of the cloud service? Have you hit your service limits? Was there a scheduled maintenance event you didn't know about for one of your instances? These are all factors that should be monitored for cloud resources, as they have the potential to impact the availability of your applications. And for AWS, some of this information is available via Trusted Advisor, as Sam mentioned, but again, looking at the whole picture and getting context is important. Being able to see an alert for a scheduled reboot alongside an alert for a non-responsive application is going to result in a much shorter issue to resolution time than if you had to get those pieces of information separately and connect the dots yourself. So using a tool that's going to provide this availability data alongside performance data will make your monitoring more efficient. Logic Monitor provides out-of-the-box automated monitoring for these account-level service limits, and we have a lot of customers that are migrating to the cloud and don't know that service limits even exist. And so by monitoring service limit utilization, we really help these customers avoid issues where they're counting on the cloud's unlimited scalability to scale their applications with customer load, when in fact that scalability is not available to them because their service limit usage is saturated. So we're pulling service limit utilization from Trusted Advisor, but we also pull it via the AWS service-specific APIs where possible. And then we present that in Logic Monitor alongside the rest of your monitored infrastructure. We also monitor all provider-scheduled events via the EC2 API. So when AWS is going to retire an instance or schedule it for reboot, we tell you that in advance with an alert. So it's essential that you're looking at the whole picture and considering more than just individual resource performance. And then beyond that, you'll need to have enough visibility to distinguish issues in your environment from issues on the cloud provider end. And this really requires that you have an extensible monitoring tool that can handle data from multiple sources and that can keep up with change. Sorry, there's a lag here. And for the ROI monitoring, the goal should really be to keep an eye on costs to, number one, avoid unexpected charges or surprises, but also number two, to figure out where costs can be optimized. Having a granular billing based on per second running times is great from a cost savings perspective, but it's complex when you're trying to analyze and understand your bill. And so having a platform that will monitor billing data and show you how it's trending this month and how it's been trending over the past few months and break it down in a way that makes sense for your business is really valuable. And a lot of times this monitoring is monitoring but spend by custom tag, because companies tend to tag resources in the cloud based on what makes sense for their environment. And then beyond just being able to see monitored spend, allowing you to see performance data in the same platform as spend data means you're able to look at cost optimization, not just from a how much am I spending angle and what does that breakdown look like, but also from a utilization perspective. So look at your bottom 10 EC2 instances by CPU utilization. Is there anything sitting idle for a long period of time that you can resize or get rid of? How many unattached EBS volumes do you have lying around that can be cleaned up? And again, this is really where context is everything. Looking at performance utilization and spend in the same platform opens up a new set of doors. And so having a platform that can show you both in a single pane of glass is going to help you from a monitoring perspective. At Logic Monitor, we pull in spend data just like performance data, and make it clear where you can optimize costs. We pull in information from AWS cost and usage reports and break that monitored spend down by service, by region, by tag, and then also by account for consolidated billing setup. And you can actually use this in conjunction with our forecasting functionality to analyze future spend based on historical spend. And then we'll also monitor reserved instance offer expirations. So we'll auto-detect all offers and monitor their time until expiration. And of course, expiration of these offers isn't a huge performance impact, but it can be a pretty big jump in spend. And then we'll keep track of the instances purchased with each offer, so it's easy to look at how many are running in comparison and get an idea for the utilization of each. All right, so on to strategy number 2, automate everything. So modern technologies like cloud services really do enable you to scale quickly, but if you're manually managing your monitoring environment to add resources into monitoring, for example, you're really reducing the value of using a scalable modern technology. Similarly, using an orchestration tool like Puppet, Ansible, or Chef can help speed up deployments and scaling, but having a monitoring tool without built-in automation to match the orchestration tool can reduce the value, because it means you have to find a way to ensure your monitoring tool is always up to date. So ensuring that your monitoring tool has automation built in, or at least provides a toolkit like an API that you can use to automate things yourself, is critical. Logic Monitor has this automation built in. We provide several methods for automating resource discovery and deletion, and this is particularly robust around our cloud monitoring, where you can provide us with read-only access to your resources, and we'll make sure that everything gets added and removed from monitoring automatically. And then we also have a myriad of integrations with tools like Puppet, Ansible, and Terraform, and a REST API that makes additional, more custom integration possible. So ideally, you should be integrating tools you use in your ecosystem with your monitoring tool, because that reduces manual effort and the likelihood of an error being made and increases the efficiency of your operation. And the same automation principles really apply to alerting. So it's great if you have the monitored metrics, but arguably the most critical aspect of having them is to know and act when they exceed reasonable ranges. Relying on a manual process of someone identifying a metric out of the norm isn't going to cut it. And having those reasonable ranges be, well, reasonable is really important. You don't want to set thresholds too low and flood your team with alerts. This leads to alert fatigue and usually results in the team not valuing alerts as much. And then when that critical issue does come through, it may just get lost in the noise. But it can take a lot of time to determine where to set thresholds. And relying on manual configuration of when these alerts should be triggered is also going to reduce value. So how do you automate this? Well, tools like Logic Monitor have built-in thresholds. So we have a monitoring engineering team that publishes and maintains our monitoring templates, and they set default thresholds based on industry standards, among other research and information. And this is really valuable because you have a starting point, and all of the work to get to that starting point was automated and done for you. So we'll determine what needs to be monitored and what reasonable alert thresholds are. And maybe you're migrating to the cloud and are unaware of the service limits that are imposed for your account. Logic Monitor triggers alerts at 85% usage for service limits by default. And okay, so that's the triggering of alerts, but how do you ensure that those alerts are going to the right people? You don't want to have to rely on sending alerts to the same person and having them forward to the right person every time, or hoping that someone logs in to see alerts. You want to make sure that you're able to dynamically route alerts to dev and ops teams members based on the resources that they own. So maybe all app-specific alerts go to dev and underlying infrastructure alerts go to ops. Or maybe all alerts pertaining to a particular AWS account go to both. With Logic Monitor, you can set up rules that determine how alerts are routed via text, email, or integration based on the resource and alert and other criteria. And you can have alerts escalate to other people if nobody responds to the alert, thereby ensuring that someone sees and takes action. And then the same goes for visualization. So there's a lot of power in visualizing monitored infrastructure and applications. A dashboard that is strategically set up to reflect your application enables you to look at alerts in the context of your application and really allows you to compare which components are working and which aren't, which typically helps you quickly identify which component is causing the underlying issue. But you shouldn't have to manually configure these dashboards every time. Logic Monitor provides automated dashboards for cloud services and templated dashboards for everything else. So you can simply replace a variable value to point to the resources you want to display data for, and the dashboard should populate with data. You can export and import these dashboards to quickly replicate across similar apps, and the intention is really to make it easy to visualize your monitored resources in a way that makes sense for your environment. All right, so on to the third strategy. So IT transformation is a popular concept right now, and it's all about transforming infrastructure to support modern applications. But this includes the challenges of figuring out how you maintain visibility into your scaling infrastructure and automation such that monitoring isn't slowing you down. And the challenge of dealing with new technologies that are very different in terms of resource lifetime and in terms of what data they expose. Ephemeral resources are becoming more and more prevalent. Technologies like container and container orchestration tools almost act as a unifying layer across the top of hybrid environments. And one of the major benefits is that they don't care where they're running. They should do the same thing whether running in the cloud versus on premises. But there's a clear trend of decreasing resource lifetimes. And it can be challenging with such short resource lifespans to ensure that your monitoring is meaningful. Resources are coming and going quickly, and so obviously automating resource additions and deletions is important. But additionally, the health of the service or application that the resources are serving becomes almost more important than the health of the individual resources themselves. With customizable monitoring templates and automated resource discovery and deletion, Logic Monitor is super extensible, so you can really extend it to monitor whatever you want. But the strategy here is really to make sure that you have a monitoring tool that can handle this kind of change. You want a monitoring tool that enables you to focus more on growing your business and less on making sure that you have a monitoring tool that can keep up. And then to tack onto this, another reason to really use an extensible platform beyond preparing for the technology of tomorrow is because there's no such thing as a one-size-fits-all monitoring tool. One-size-fits-all monitoring solutions, which really lack the flexibility to customize monitored data, rely on grand promises of universal compatibility. However, such platforms often result in less value and more noise post-deployment. The modern production infrastructure requires more customization than the one-size-fits-all solution can deliver. Not only does Logic Monitor give you the best possible starting point when it comes to performance monitoring, but we also provide you with the tools you need to tailor your monitoring to fit your specific needs. So let's put this in the context of monitoring for AWS resources. For default CloudWatch data, only non-zero metrics get reported to the CloudWatch service, which makes it more challenging to tell the difference between a functioning AWS resource that isn't doing anything and a misconfigured AWS integration. At Logic Monitor, we can create a status for CloudWatch data based on the response of an API request for a metric that should never be zero. And so sometimes this is a status directly reported by CloudWatch, other times it's just a metric that should always have data. And we can then correct CloudWatch metrics data based on this status. So the resulting status corrected data is 0 if the status is okay and we didn't get any data from CloudWatch, and no data if the status is not okay and we didn't get any data from CloudWatch. And this enables us to report 0 values and no data. And then in another vein, what if you want to perform a calculation on the performance data for your resources, such as net SQS messages per second, or the ratio of sent messages to deleted messages? Using a monitoring tool that makes this possible ensures you'll be able to look at the metrics that are most relevant for your environment. With Logic Monitor, it's really easy to perform a calculation on a data point. As you can see in the image here, we're calculating the percentage of backend errors on an ELB per second that fall into the 400 range. And then in terms of customizability for what data is actually brought in, you can write custom monitoring templates where needed in Logic Monitor. So while our long list of CloudWatch integrations and library of Logic modules provides comprehensive monitoring for AWS resources out of the box, we also offer the AWS Java SDK as a part of our collector. And the built-in AWS SDK really acts as a toolbox that you can use to customize the information you see in your environment, ensuring it aligns with your team's particular focus and goals. So again, the strategy here is really to make sure that you're using an extensible monitoring platform that's going to be able to grow with you as your environment changes, especially with today's ever-changing IT landscape. So that really rounds up what I wanted to present today, so I'll just quickly restate the 3 strategies that I covered. So number 1, looking at the whole picture. So making sure that you're monitoring not just resource performance across wherever your resources may be, whether in the cloud or on premises, but also looking at the availability of the cloud services you rely on and the ROI for your cloud investment. And then number 2, making sure that you're automating the processes around monitoring, so you're not losing the value associated with the scalability and the flexibility that cloud services and containers and other modern technologies enable. And then lastly, make sure your monitoring tool is going to be able to keep up as you iterate and incorporate new technologies into your environment, and that it isn't going to end up slowing you down. So I'm going to pass it over to Krista, who's going to wrap things up for us today.
Great. Thanks so much to both Sarah and Sam. I see a few questions that came through the chat line, but before we get to those, I wanted to leave you with a pretty cool Logic Monitor and AWS success story from Infor, who implemented the strategies that Sarah and Sam highlighted just now. Infor has an astounding global footprint. If you haven't heard of the company, they are an enterprise software provider to more than 90,000 customers spread across 170 countries worldwide. So in order to support their wide range purpose-built applications, Infor leverages a substantial and pretty sophisticated deployment in AWS. It's actually one of the largest AWS deployments in North America. So Infor's deployment runs more than 14,000 EC2 instances, as well as ECS, Elasticsearch, autoscaling, Lambda, and many more. As you can imagine, maintaining visibility into the 50,000 AWS resources supporting their application solutions is not a trivial task. To learn full details on how Infor was able to successfully use Logic Monitor to support their AWS deployment, I encourage you all to check out the case study in the Bright Talk attachment at this webinar page. So with that, there are a couple of questions to address from the audience. And Sarah, this first one is for you. The viewer is wondering if the monitoring CloudWatch and other listed information will also work with Azure Cloud.
Yes, it will. So we apply these same principles across different cloud providers that we monitor. So we'll pull in information from AWS, but we'll also monitor resources within Azure Cloud. So we use the Azure Monitor API to pull in the resource performance data, and then similar to what I talked about during the presentation, we're also pulling in usage for service limit and working on incorporating the billing monitoring as well.
Great. And then another viewer had a question on, will our collector interface with InfluxDB architectures?
Yeah, so the great thing about our collector is you can write monitoring templates to monitor pretty much anything. So it can, speak all of the traditional protocols like SNMP, WMI, JDBC, etc. But you can also write custom script data sources to interface directly with an API or anything that exposes data. We can pull it into the platform.
Awesome. Question number 3 here. Touching on automated deletion of cloud resources, how can we differentiate between resources that we care about being deleted, such as single instance deployments, or resources that we don't necessarily care about, like auto-scaling instances?
So you can configure how frequently resources are deleted, and you can actually change that frequency for different services. So for example, you could have EC2 instances for an auto-scaling group being deleted more frequently than EC2 instances that are outside of an auto-scaling group. and really customize how things are deleted for your account. So it's pretty configurable. And then we also make it clear in the portal when things are marked for deletion and give you the exact date that the deletion is going to happen on. So if it's not immediate, you can run a report and be looking at what types of resources are, in the queue to be deleted pretty soon, and what they're tagged with, and all of that metadata that you'd want to see alongside it.
Excellent. And then how about, we've got one more. How important is data retention in a monitoring tool? And does Logic Monitor aggregate data over time?
Yeah, so data retention is very important for looking at historical trends, especially if you're relying on monitor data to look back and draw correlations. So at Logic Monitor, we can retain all data at full granularity for over 2 years. So we're actually not aggregating data or losing granularity over time. We keep everything.
Okay, and can you pull CloudTrail events into Logic Monitor?
You can. So Logic Monitor is not a log aggregation tool, but you can pull select events in to view alongside your performance data. And since we include AWS's SDK with our collector, you could use that, for example, to pull and select CloudTrail events that match a specific query or criteria, such as changes to security groups in your account.
All right, that's actually a good segue into this next question, which is how does Logic Monitor fit in with logging and APM tools?
Yeah, so Logic Monitor is primarily an infrastructure monitoring tool, so we're not a log aggregation tool, as I previously mentioned, though we can monitor information from logs such as select events or counts of events that meet a specific query, but we're not a traditional APM tool either, where you have something instrumented at the code level that's going to look at traces and tell you, for example, your slowest line of code. We really see ourselves as complementary to that, because once you do find your slowest line of code, you need to identify why it's slow. Are the database connections maxed out? Is the CPU spiking? And so that's really where Logic Monitor comes into play. And then we do have some website monitoring that you can do to test your applications from an end user perspective. So things like testing, logging in, and performing a couple of key actions that you want to ensure your end users can do for your app.
All right, thanks, Sarah. And with that, we are going to wrap it up as we are coming to the end of the hour here. If we didn't get to your question today, we will follow up with an answer over email. So thank you all for joining us. We really appreciate you tuning in, and we hope you found the webcast informative and enjoyable. Big thank you to the AWS team for sharing their perspective as well. As I mentioned earlier, the on-demand version of this webinar will be available shortly. You can access it with the same link you used to sign up. There are some great reference points in there, and certainly take advantage of the material we've made available to you in the attachment section on BrightTalk. We noticed that the actual deck wasn't in the attachment section, so don't worry, you guys will all receive a copy of this deck as a follow-up. If you have any questions, feel free to email us at webinars@logicmonitor.com, or you can reach out to Sarah Terry directly in the email provided in the deck. So that is a wrap, everyone. Thank you again for joining, and have a great rest of your day. And thanks, AWS.
Thank you.
Thanks, Kristen. Thanks, Sarah. Bye.
Bye, everyone.